Okay. All right. So, practice guides for your unit test, the chapter test we have tomorrow. Get that out right now. We're gonna do the chapter test first. That's the priority today. I'll explain different things. Your hood. Thank you. All right. Okay. Homework today. Homework, page 3.4.5. That's the system stuff. That's due today. Get it turned in. Okay, that can be in the back and the front. I'll take those here in a minute. Now, other things. Let's talk through our chapter test. Okay, we started this yesterday. If you were gone, you missed the first half, you'll either need to come in, ask questions, or after school, or before school tomorrow. Okay? So just be aware of that. And if you're coming in tomorrow, it's first come, first serve. So if you're in here last, you're the last to get questions answered. That's how it works. Okay, I had some people email me last night. You just got to come in. Okay. So, all right. So vocab, there'll be 6 words, a big word bank. I'll put the word bank in the box so you can kind of clearly know them. Number 2, I'll have a new word bank there so you know what questions or what answers you can put. 3, you have to find X and Y. It'll be kind of easy. 4 will be more of a challenge because you have to actually plug it back in and solve. All right, we're starting with 5 today, and we're going to work our way to the end. These are pretty simple. I'll explain once we get there what we're going to do with these. Okay? All right. Does everyone have their unit test for chapter 3 out? Better go fast. Everybody missed what we're talking about. Okay. All right. Everyone's got their practice guides. All right. Now, if you're looking at problem 5 and 6, they're the same type of question. Now, why did I put 2 different ones there? Number 1. On number 5, you can literally count with your fingers. Okay, guys, seriously, shut up. So, you can count with your fingers, count up, rise, run, you can do that way. On number 6, you can't do that. You have to actually use the formula. I would just recommend using the formula from right off the bat. Okay, so here we go. Here's the formula you need to use. This is rise over run. This formula will be on the board. It'll be probably over there on test day. So that'll be tomorrow. I'll probably have it over there because I'll have all the linear equations written over there because my pre-calc class also needs them. So they'll be out on that side of the board. All right. So for slope, we have to have the y coordinates. We have to have the x coordinates. I need to know the coordinates for G and F right now. So what's the coordinate for G? -5. Okay, the coordinate for F. 6, 2. All right, that's what we need to know first. You will have to go find those coordinates because those are the numbers I'm going to use in my formula here for number 5. Now, with the -2, -5, the 6, 2, which numbers are the y numbers? Yeah, the back numbers. They're alphabetical. So the back numbers are the y numbers. So you're going to have to subtract those. I don't care the order that you go, but you have to subtract those numbers, the y numbers. So in my case, I'll go top minus bottom. 2 minus the -5. So that's what you have to do for the y numbers. For the x's, I'll go top minus bottom again. 6 minus the -2. Yes, you always subtract whatever the numbers are. Even if they're negative, you still subtract the negative. Now what happens to the 2 negative signs here?
Positive.
That makes positive, so this will make plus plus, which is 7. The 2 negative signs here cancel, which makes 8. And that should be right. It should be rising 7, running 8. You can count with your fingers and still get the same answer. I'm totally fine with you doing that on the first one. Because if you don't believe me, you start here. I go up 1, 2, 3, 4, 5, 6, 7. And I run 1, 2, 3, 4, 5, 6, 7, 8. I run rise 7, run 8. You could do it that way. But the rise number has to go on the top, the run number has to go on the bottom. Now the reason why I use the formula is never wrong. What goes wrong for most people is counting with their fingers on the graph because they lose track or they went their own direction. Instead of going up, maybe they're going down instead, so they got negatives. All right, questions on the slope. And that 7, 8 slope makes sense. It's a positive slope. The graph is going up to the right. That is positive. All right, questions at all about the first one? Number 6 is the same exact formula. You have to find slope using the same formula, but number 6 doesn't have the graph, so you can't just count with your fingers like I did number 5. Because some people just count it. They're really good at just looking at that problem and just counting it off. Does anyone still need number 5? Can I erase it?
Yep.
We're good? Okay. Alright. Then we're into that. We're gonna scroll down. I'm gonna zoom in here to make this a little bit bigger. 6 is a little bit small. Alright, so we're gonna find slope here on number 6. Okay, we have to use the same format. Now, what are my y numbers up here?
1 and 1.
1 and 1. We have to subtract those. So 1 minus 1. I'm going to go this direction. 1 minus the 1 backwards. First minus the back. Okay? Just put pass on my desk or in the back of your phone. Okay, alright, so 1 minus 1. Perfect, thanks. Alright, and then on the bottom, I'm going to subtract the x numbers. So since I went the front minus the back, I'm going to go front minus the back again. So I'm going 3 minus the -2. And yes, you always subtract them, whatever they are. Remember, y numbers are on the top. Don't forget that. The y numbers have to be on the top. So on this one, this turns out to be, what's 1 minus 1?
0.
0, and 3 plus 2
5.
is 5. This is 0 slope. You identified what type of slope it is, because it does say that in the directions. It is 0 slope. There's 4 types of slope. There's positive slope, negative slope, 0 slope, and there's undefined slope. So you've identified the 0 slope. It's 0. 0 divided by anything is 0. Questions at all about number 6? Hopefully that is easy. Like, number 5 and 6 are meant to be quick problems. Like, if you know how to do it, you're fine. If that's something that you're going to be stuck on, yeah, you're deserving this much points because it's kind of easy. You did that a lot in Algebra 1. We'll get to number 6. Okay, let's move on to 7. 7 is by far the more challenging one on this whole page, I believe. You have to do a lot of stuff. We did some homework on this, but it's been a while. It's been like a week or so. So let's talk about number 7. I need to zoom out a little bit. Okay, I'll do 2 different problems for 7 so you get a kind of a chance to see this one. Alright, so for number 7, you're drawing. Number 1, we have to graph, so that's why I give you the graph paper off to the side. Number 2, we have to come up with the equation in point slope form. So that's the reason why I was trying to explain to you a lot in the previous sections when we did this stuff, to know the forms of linear equations. Like, why do we have them? One is really good for graphing, one is really good if I need the equation, the form from the data. I'm giving you a bunch of data and a graph, and you have to come up with an equation for it. That's why I want you to put it in point slope form. There's a whole rhyme and reason to my madness when I describe that stuff. Okay, so we'll go through this. The goal is to pass through this dot, that dot, but we have to be parallel to this. So that means that BC is its own separate line. What I'd like you to do right now is go on your graph and draw BC right now. So that's 1, 3, 4, 5, label B and C, draw the line. That's its own separate line. So 1, 3, 4, 5. So here's B, 4, 5. Here's C. This is what your first line should look like, something like that. One, 3, 4, 5. Okay, so you already got a couple points for drawing. Next, we have to pass through 2, -5. Where is A going to be found? What quadrant?
4.
4? Okay,
Yeah.
2 over 5 now. 1, 2, 3, 4, 5. So here's A. So I have to pass through A, but I want to be parallel to BC. What does parallel mean?
Same slope.
Same slope. Say it
Won't
again.
ever intersect.
Never intersects or touch. They're on the same plane. So these are good things. So we know we're going to draw a line that will never touch, never intersect, and it will have the same slope. So that's how we're going to guarantee that it will draw this the right direction. So what we have to do here, to draw this so that it is perfectly parallel, we have to find slope. Why do you think you just practiced it twice up above? We did 5 and 6. We have to find slope here. So what are the numbers I'm going to subtract to find slope? What are my y numbers?
3 and 5.
3 and 5 are the y numbers, and 1 and 4 are the x numbers. Yeah, we'll go that route. 3 minus the 5, 1 minus the 4 go on the bottom. Remember, y numbers go on the top. It is important that you know the y numbers go on the top. The x numbers go on the bottom. So what does my slope turn out to be? 2 over 3? No. There's -2 over -3, which the negative signs cancel. So the slope is going positive up 2 over 3. I can draw that. Start at A, go up 2 over 3. up 2 over 3, up 2 over 3, and then you can draw that thing. So, does it look like it's parallel? Perfect. And that's easy enough. I can handle that. But now, the last thing. So you got a bunch of points we're drawing, because it did say graph. Second part, you have to come with the equation for it. You have to come with the equation that represents that data. So, that's where point slope comes in. The most difficult part about this is knowing what the forms are. They'll be written on the board. They're going to be over there. I ain't hand over it. Okay? So they're going to be in that big white space. I'll have all of them. They'll be clearly labeled, everything. You'll have everything you need. So, point slope forms. Here it is. This is the form that you'll see on the board. It'll be clearly labeled. That's the form. That's what we use when you have data and you need to come up with an equation for it. So the equation, what's my slope? 2 over 3. We know that. What's the coordinate that I need to pass through? What's the coordinate that I'm passing through?
2, -5.
2, -5. This is the one that I'm going to plug into my coordinate, into the formula, because that's the one I have to pass through. So the A number, or sorry, the X number is the 2. That number goes here. That number is the X. It goes with the X. The -5 is the Y number. That will go with the Y. And yes, I always leave the subtraction signs there. So the Y minus whatever the Y number is, X minus whatever the X number is. There's your formula. This is what I'm looking for. Boom. Easy as problem. You have your coordinate for X plugged in, you have your Y coordinate plugged in, you have your slope plugged in. The only difference I could put here on this problem, instead of writing parallel, I could write perpendicular instead. The difference in perpendicular would be this. So here's that line we drew earlier. That's the A comma, or that's the B comma C part. A was down here. The difference would be on perpendicular, it would make an L shape. That's what the drawing would do. So how we figured out the drawing, how do we draw that? The slope changes. Instead of having 2 over 3 to be perpendicular, so instead of parallel, I want to be perpendicular. You just flip the slope over. My slope was 2 over 3, so I'm going to flip it over to make it -3 over 2. And that will guarantee that it'll draw the right line. You just flip it over. Okay, and then you do the same coordinate. In fact, I'm going to move the camera so the camera can see it. I don't think it's in camera shot. So, to make that one, to make the equation for it, to make sure that it's going down 3 over 2, again, that's just flipping the slope over, making it opposite. The formula for it, the formula that we came up with earlier, was this, y minus the -5, the slope plugged in, x minus the 2. My slope would go here for perpendicular. That would be the only difference. It would still have the same coordinate that I passed through. Does everyone see how I came up with those? Perpendicular versus parallel. Parallel, you use the same slope. Perpendicular, you do what they call the opposite reciprocal. You flip the slope over and make it negative. Or make it positive if it was negative. Okay, questions on number 7. It's meant to be simple. Drawing it should be the easy part. Coming up with the equation will take a little bit of work, because you have to come up with the slope and all that good stuff. Does everyone understand where the numbers come from, where they go? Okay, let's go back to number 8, and this will be our last one for this practice guide. Okay, let's do number 8 here. Alright, so number 8, let's scroll down so you can see it. Okay, this one, we have to do a system. Let's zoom in here so we can see it a little bit better. Alright, we have to do a system on this problem. You're not allowed to draw it because I didn't give you a graph. So you have to do it by the actual elimination method to figure it out. So we have to pick a letter, because they're already stacked perfectly. This is what you have to do in your homework today. That was due today anyway. So, you have to pick a letter. Let's pick one. Y or X's? Raise your hand if you want X's. Raise your hand if you want Y's. I'm going with X's, sorry, you got outnumbered. Okay, for X's, we're just going to pick the X, so we're going to multiply by 3 on the bottom. I want to make them both 3's. So on the top one, I'm going to leave this equation alone. That equation already had a 3 there. The bottom one, I'm going to multiply the whole row by 3. So multiplying the bottom row by 3, I get 3x. Again, this is how I'm doing it. 3x, 12y, and then 26 times 3 is an 8, carry 1, 78. That's 26 times 3. Everyone understand how I got that bottom row? Multiplying that second row by 3. Okay, now we have to make them opposites. So what I mean by opposites, you have to make one of the rows negative, because my numbers are exactly the same. I need to make one of them negative. So I'll just make the top row negative. If any of the numbers are negative, they turn positive. That's how it works. Okay, once we have that, and they're already opposites, you might not even have to do that. Maybe they're already opposites, you can just add straight down. If we add these together, the x's cancel. That's eliminating. The negative 1 and 12 make 11. And negative 12 and 78 make what, 66? So my y would have to be 6. Because you divide by 11. That's a nice clean number. I think there was only one problem in your whole worksheet that turned out to be a decimal, I think. The graphing is a different story, but the actual answers, I think there's only one. Now, what do we have to do with the 6? Plug it back in. And it doesn't matter which one you plug it back into. You can plug it back into the top equation or bottom equation. It does not matter at all. I'll just pick the second equation here. It really doesn't make a difference. If you like the top equation, pick the top one. I just pick the bottom one. And I'm going to plug this y back in. So for me, I'm plugging the 6 back into the y location. So this is what I have. And so I can kind of figure out by using common sense that if this is 24 and the answer is supposed to be 26, my x should have been a 2. 2 plus 24 is 26. So it turned out to be a nice clean number. Test day, it'll be a clean number. I'm not going to pick a weird decimal. I'll pick one that you can easily get to an answer and they work out nice and pretty. They can be any number really. It could be decimals, it could be that, but on test day I'll make sure it's a nice full number. They can be negative though, still. Questions? All right, that's what you're doing on your worksheet that you had to do today. A lot of them you had to do this first, this type. This is called an elimination method. Then you had to go graph them right away. Where you had to change them to slope-intercept form and go graph. Slope-intercept form is you move the x's over first, and then you divide by the number from the y second. That's where you could get some weird decimals, but when you draw, they should always cross. Okay, we're good so far. Okay, practice semester test. Take it out. This is our last thing today. Josie, I think you're about to leave in a minute. So, good luck in your interview. All right.
What? You working good? What are you talking about, Kai?
No, I was adjusting.
That's a Christmas
Okay, all right, today. Now, Josie, I'll have to explain some rules before you leave here in about a minute. Okay, today, what we're going to do today, yesterday we did 1 through 3, or sorry, that was Tuesday we did 1 through 3. Yesterday we did 4 and 5 on this thing. Today we're going to do 6 and 7, I believe. Is that right? Yeah, 6 and 7. We're doing 6 and 7 today. There's a slight change. What I mean by slight change, number 7 for your semester test day will have different instructions. The reason why, I was told yesterday in our meetings that we had that at least one problem in your semester tests that we all have changed, that we all have made as teachers, one problem has to be changed and it has to be a certain format. Okay? It has to be one question in the test. You get to pick the question. I picked number 7 because I figured that was the one problem that you didn't like the most, and I changed it to what the new rules have to be for us. So I'll explain today. Okay? Yeah. So I'll explain. It'll be a lot easier than what you have right there. All right. So it's a good thing that you're getting a different problem for number 7. 7 is kind of challenging. So I made it a lot easier than what you're going to have to do, but I'll explain. So Dosia, when you get back, maybe Monday, I'll explain it to you, or tomorrow I can even explain it to you. Okay?
Okay.
Okay. All right. Let me start inside the camera. Let's start with number 6 today. So Dosia, if you want to watch that video, you can do that. I'll have the videos online today from Tuesday and on. Just we need to kind of make sure we review.
I'm good.
So, all right. Okay. All right. So let's talk through it. I'm gonna actually go through the answers on 6 and 7 here. But I'll talk about why we have to change these. Alright, so 1, we talked about point signs and planes. 2, we talked about how to find distance or midpoint. Yesterday we did 3, 4, and 5. That was talking about, the angles, the names of the shapes, and then we talked about the different sentence structures. That was what we did yesterday, and I'll make sure that video is online today, like before the end of school. Make sure if for anyone that was gone that needs to watch those videos again. Okay, 6. I made this problem a little bit more difficult than the one I'll put on your test because it's going to cover both bases. 6 on your semester test will be an expression like this. It'll be a little bit simpler looking. I picked this problem on purpose because it has both rules in it. This problem is a mixture of distribution and a commutative problem. Okay, the one on your semester test is only going to be one or the other. It'll be just distribution or it'll be just commutative. So that way it makes your problem on your semester test 3 to 4 steps. This problem turns out to be 6 because I mixed both problems together into one. I will not do that test day. So this will be very similar, but I'll explain when we get through this. I need to make this bigger so we can see it. All right, here we go. We ready to go? Okay, so I'll explain. Number 1, we have to distribute the 5. So this, if your problem is a distribution problem, these first 3 steps are what you're going to have to do in your test for semester test day. And then I'll draw a line and I'll talk about what if your problem is different. Okay, so we'll distribute the 5. So that means you hand the 5 to the 2x, you hand the 5 to the 3. The 3x in the back, the 1 is back there. That is distribution. You hand it out. Notice, I didn't write down 10, I didn't write down 15, you just handed the 5 to each. It's like when your mailman puts the mail in the mailbox. They didn't open it, they just put it in the mailbox. Alright, now, the second step, we have to move the parentheses. What property is that when you move parentheses around?
Commutative.
Not commutative.
Associative.
Associative. Okay, associative, we're going to move the parentheses bars. The numbers are not moving, that's why it's not commutative. Just the bars are moving, so that's associative. So the numbers can actually see each other. It's associative. And don't abbreviate it. So let's spell them out. Now, you can use your property sheets on the semester test. So the property sheets I gave you a long time ago for that last chapter test we did. You can use those. If you lost those, go back and print out the sheet. All right. Now we can do the math. What's 5 times 2? 10. 5 times 3? 15. Minus 3x plus 1. All right, that's substitution. Now, on your semester test, if it was a distribution problem, you'd be done.
So can't you combine the x's?
Yeah, that's why this problem's different. Because I put multiple x's, multiple numbers here. So if it was a normal distribution problem, that's probably where you'd stop. But since, like, if you didn't hear Olivia, we have a bunch of x's, we have a bunch of numbers. We have to combine those. So I mixed 2 problems into one. But does everyone understand, like, that would be a 3-step problem if that's all you have to do? But we have to keep going. So now this, I put a line here on purpose, because maybe your problem just looks like this on test day. So you just distribute. That would be a 3-step problem. Maybe your problem starts like this on test day, starts here. So then what you'd have to do is the next 3 steps, you simplify. So it's one or the other. I'm not trying to make a really difficult problem. I'm just showing you what I could have, and this problem covers both bases. So, if we move things around, we have to move the x's next to each other, right? So what was that, Turk, you were saying earlier?
What did I say? So, commutative.
Commutative. Good. So it's commutative. You're moving things together. So I move the x's next to each other, I move the numbers next to each other. I can't just write 7x yet. The x's can't see each other. So I just moved them next to each other. Now I'm going to factor out the x's. So this is called factoring. You actually take so the numbers can see each other. It's not associative. There was no parentheses that I moved. I didn't even have them in the first place. So this is called factoring, or reverse distribution. Reverse distribution. Okay, factoring and reverse distribution. So then what we'll do is now that we factored out the x, now we can simplify. What is 10 minus 3? 7. And 15 plus 1? 16, that's substitution, so that would be your other 3 step. So if your problem was just a commutative problem, you move things around, fine, it's commutative, it's 3 steps. If it's distribution, it's 3 steps. You have to have your property sheets, so hopefully you remember those properties. I think you guys can handle that. I don't even know if you'll need your property sheets, if that's all you have to do, 3 steps. You just have to remember which 3 steps you have to do. Okay, does that make sense? It'll either be the top or it'll be the bottom. I just made a problem that had both, so you can see it. There, we good? All right. Again, I called it factoring or reverse distribution. We're going to call it. No, wait. Okay, number 7. This is our last problem of the day. I'm going to explain why we have to change the format. Now, I will do number 7 for you today so we get it done, it's out of the way. But we have to talk about how this problem is going to change test day, because we have brand new rules and instructions. Okay? All right, so. Okay. Okay, is everyone good? Everyone's got number 6? Okay, let's go to number 7. All right. Now, I'm going to explain how this thing has changed. Don't get me wrong. Like, I know when people see this problem, they get, they get nervous. They don't like it. It's got a lot of geometry problems in it. Some people are just not very good at the geometry-based proof. I understand that. I was told yesterday in our meetings that we had after school that one of your problems on your semester test has to change directions. It wasn't just me, it was every teacher in the school has to change one problem on their test. This is the problem that I'm going to change. The reason why is most people are not very good at this, so it actually makes the problem a little bit better for you guys in the long run anyway. But what we have to do, every teacher has to do this, it has to be in a race format. So if you don't know what a race format is, that's where you restate the question, you answer it right away in the first sentence, then you come up with evidence and you expand on the evidence, right?
We just learned this in American.
Yeah. Okay, yeah. Every teacher has to do it. So I thought the best way I can change this problem, because this is a nightmare for most people. They poop themselves when they see this thing. They don't want to do it. So I changed the problem so it's a little bit easier for you guys. So for the race format, I was thinking, how do I change the problem so it makes more sense to people? Here's how I'm going to do it. This is the problem I'm going to do. Okay, let me get rid of this. I'm just going to zoom in so I just have white. All right. So zoom in. All right. So just imagine I have a big white space. That's about as good as I can make it. All right. So here's how I change the problem. We'll get back to number 7 here in a minute, but this is what it would be. It would be something like this. Say this is A and B. Say this is a 2x plus 1. This is B and C. And this would be an 11. Okay? And my question, what I would give you is I would say, given AB is congruent to, let's say CD, or DC, sorry. Okay? Saying that those are congruent, I would say, prove the following and explain why. So what I mean by prove and explain. If you look at this problem, what does congruent mean? Equal to. So these two things would be equal, right? So 2x plus 1 would equal 11. Do this math in your head in 2 seconds. What's the answer?
X.
5. Okay, that would be your first line in a race car format. You'd go, that the proof of this one, or the solution for this problem is x equals 5. Boom. Your first sentence, you stated what you're trying to prove and what the answer was. X is 5. What you have to do in the race car format after the first sentence, like the proof of this, or the solution for this problem is x equals 5. Because, and now you go into your paragraph and you explain in one paragraph why x is 5. So, how would I explain this? How this would be a race car format for you, because it makes it a lot easier, right? Easier than the problem I have on my semester practice guide here. So, how would I explain this? Other than the first sentence saying that x is 5. Because, number 1, you guys just even said it. What does congruent mean? It means these two segments, AB is equal to DC. So that'd be because these two things are equal. I would substitute in x plus 1 equals 11. So I actually say that in words. I'd substitute 2x plus 1 equals 11. Then I would subtract 1 to both sides, getting 2x equals 10, using subtraction property of equality. And I would divide both sides by 2, using division property of equality, x is 5. Done. Boom, you got all your points, you move on to the next problem. You can do the shortcuts on that. You don't have to write every step, but you have to give me evidence why x is 5. Does that make sense? I'm trying to make the problem easier for you so you don't have the panic attack when you see it. It's just an algebra problem. I'm going to make it an algebra 1 problem, but it has a geometry shape on it. Does that make sense now? but you have to do race car format. So what I mean by race car, it has to have the correct punctuation, capital letters, sentence format. I have to grade it like an English sentence of paper. I have an actual rubric that I have to use to actually grade the thing. So every class is doing it. Now you're probably thinking, why, Ward? This is math. We're told we have to, so I have to comply with that. And number two, your Iowa test of basic skills this year, the ITBS testing that you guys always do your bubble sheets, is completely different this year. Iowa's completely changed the test. It is race car format for most of the test. So you have to write down answers and explain. The reason why, and I understand why they're doing it, because it's not hard. Like to explain this problem, it takes one paragraph. The reason why they're doing it is because it promotes higher level thinking, and number two, you can't just guess. You can't do that anymore. Guessing, because on the ITBS you had a 1 in 4 chance, A, B, C, D. You can't do that anymore. Now you have to explain in words why it works. So this is the problem I picked. You're welcome that I picked an easy one. Okay, but that's coming up soon. So every class is doing this. One problem on your semester test has to be a race car format. You have to be able to explain it in words the best you can. Does that make sense how I'm going to do it for you guys?
Yes.
Okay, let's get to your problem. Let's do number 7 so we get 7 out of the way. So you get your points for it, but it will not be this way on the test, so it'll be this format where you have to do the race car and explain it in words. Okay, it'll be easy. You're welcome that it's a lot easier than what I just put on. And the worst part was, I already had my test printed. I had to go throw those away and reprint. So that was fun.
So wait, does that mean that they have to actually like?
They mark me wrong,
I have to check it.
No, the.
Oh, yeah. Oh, yeah.
I literally told them.
There's somebody's checking.
Fun for them.
Pray to God it's not me. Okay, alright. Hey. Alright, let's go through number 7. I'm going to walk you through this one. It will take us 7 steps to do this problem. I've already done it once today. You need to keep up. I'm going to blitz through my way through it. Again, this will not be the problem that I have on the test day. I'm just going through it right now so you see it and we get it out of the way and it's already answered. Ready to go? Okay, here we go. Number 1. What do we have to start with? Yep. WX, congruent to YZ. Okay, I'm going to mark that on the picture. WX, YZ are equal. That is given. Okay, we're going to go through the 7-step process here, so be ready to go. 2, we have to write that they're equal. Because if they're congruent, they're also equal. WX is equal to YZ. Depth of congruent. Okay, depth of congruent, they're equal. Now, I already marked on the picture what that means. Those 2 little sticks are equal. Step 3, we have to come up with the formula, right? That's what the whole geometry-based problems are always based on. Are these angles or segments? These are segments, so we should probably do segment addition. So my formula that I'm going to do on this one, I'm going to talk about this stick versus this stick. The big stick versus the other stick. What makes WY? What are the 2 parts? WX and XY. Alright. What makes the XZ stick? XY and YZ. Alright. And that is segment addition. Alright, that's segment addition. Alright, so now why did I do that? Why did I just add those 2? Because in the end, what I'm actually trying to prove, if you actually read the problem, I am actually trying to prove that these 2 things are equal to each other, which is really difficult to show that. Because they are different things. They're different things being added. But I have to prove that they're equal to each other. That WY and XZ are the same. That's the whole thing I'm trying to prove. To do that, is there any overlap in the middle of my problem? We have to write that. The overlap is XY. XY is equal to itself. It's the same stick on the left and right side. From this stick and that stick, the XY is the same. That's the reflexive property. Reflexive, making it equal to itself. Now you're probably thinking, okay, why would you write that? Because I'm going to add that to line number 2. Establishing that these 2 things are actually equal to each other, XY and XY are the same, I can now add them to both sides of this line number 2, and I still have a balanced equation because it is still equal to itself. So on line number 5, I'm going to add that. So Wx, I'm going to add the xy to that side. So I'm adding the Wx, I'm adding the xy to it, and up here I'm going to add the xy to that part. So xy plus the yz. So I'm adding that on. So this is step 5. So I'm doing the add property of equality, adding to both sides. Add property of equality. Zoom and make this bigger. Some more wet skids. All right. Okay. Now, why did I just suddenly add the x, y's to both sides up here in line number 2? Because I just talked about it a little bit ago. What does wx plus xy make? wy. So, these two things add to make wy. These two things make wy. I'm substituting that in. And what does xy plus yz make? Xe, I'm plugging that in here. That's an xe, and that's what I'm trying to prove. So I'm substituting those things in. Well, if those two things are equal to themselves, then what are they also known as? Congruent, and that's what I'm trying to prove. So line 7, dot, dot, dot. Wy is congruent to xz. And that is the definition of congruence. Now, some people don't like that. We're walking through it today because that wasn't going to be the type of problem that I picked. It was going to be something simple where you do the geometry-based proof of it. But since we have to do race car format, I thought I'd better give you an algebra problem. You just show me an algebra how to solve the problem. Okay, but you have to give me evidence and give me all the steps. So on number 7, this problem will change on test day. You'll have to do the race car format where you write one paragraph in words, how to solve the problem out and why it works that way. You have to give me all the evidence. I'm looking for the state of the answer in the beginning by restating the question. You showed me why they're equal and how to solve it and what the answer was. In 2 or 3 sentences, 4 sentences. You gotta do the best you can. Practice guides. Okay, practice guides, this thing. I know we got it done today. If you want to study it, it's due tomorrow. If you know you're that person that's going to lose it, I'll take it. If you want to study it tonight. I will post the video of yesterday and today online tonight, like after school, before basketball. That way you can watch those videos. I'll make sure they're online. They are actually working. I'll make sure of that. And then I'll make sure I'll go back and I'll post all those videos for our semester test. Because right now the website wasn't working the best. Okay. All right. So if you want to turn those in now, we had homework due today. That was the worksheet for 3.4.5. So get those turned in.
Oh my God! You're supposed to look the other way.
All right.
Well, now I wish I didn't turn it in.
It's a 4
Now
o'clock.
I actually get it.
I didn't.
But I guess that's what the
I'm running on all
test is.
Guess what?
But that part of me kind of hopes to get a semi-degree in geometry.
So pumped for Saturday.